Okay. Okay, can you see that?
Yep.
Yeah.
Already, I've not had a chance to read this yet, but I think this section is what Alex put together. I asked him, so, and he put this note there with it as well. So why don't we just all have a chance to read that? Can you read it okay? Shall I zoom in?
Yeah, if you can make it bigger, that'd be great. It made everything bigger but his comments.
Oh yeah, that's
That's a feat. That's a feature.
I think this is his section. I think he wrote all of this. Actually, that's the trouble. I don't. When you're editing, it doesn't tell you who wrote the.
Yeah, it should have tracking turned on.
Yeah, you need to put suggesting rather than editing. Editing doesn't. Anyway, I gave people editing rights, and they can decide whether it's suggesting or not. Anyway, let's read this.
So, Alan, do you have any high-level requirement? Do you have we started the requirement for the BMC on this one before we go to the, more details about Calyptra and other security steps and SPDF stuff like that?
When you say the high level requirement, there's the two aspects of it, right? There's a hardware side of things.
Yeah. No, but I'm saying the use case requirement, right? Just a
of the whole machine, you mean?
The BMC, system management machine.
Of
Just
just
the management part of it, yeah.
So
So here is what I'm coming from, right? I think I still a little bit fuzzy on. So the system management has two parts, right? One is definitely to manage the system resources, which is internally in a very high level. If I take a 10,000 feet view, and we can definitely define, I think that's definitely it's a must requirement. We can define all those timing requirement, SPDM between attestation between devices. We can define definitely Calyptra and all those things. And also how do the management, temperature, fan control, or cooling control, or whatever it is, right? And also system health, system logging, system attach, and system presence and detects all those things. But what I don't understand is that, there has to be something that talks to the outside world, right? Because the BMC is one of the main functions of the BMC is to install the operating system, any kind of system updates, any kind of system removal, any kind of device removal, something. The BMC manages all the system inventories too. So that section, I'm still not clear who is doing it. Is the system management is doing it, or this is a different server altogether doing it?
So you're talking like a management console to update the system in. I guess we have made the sort of statement that if we do have this control plane network that we were talking about, some sort of gigabit level or maybe faster network as a sort of a mesh between all of the modules, we did say that would connect into some sort of overall system manager. And I guess I've referred to it as the DCSCM, the security control module that is the master of ceremonies, or whoever has that one. Now, I guess the way I was thinking of it is one of these modules, if you had a CPU module or whatever, one module could be assigned as being the master of the whole machine, and that could operate as a management node alone. Or we could develop a dedicated module for management purposes. I mean, it might be a little bit overkill in terms of a management node would only need to be 100 watts or so, not sort of 2 kilowatts. But that might be a good way to do it. And we were saying, could the DCSCM be integrated into the design of this what we're using from Lattice with your devices, your Avant devices? Do they have all the functionality to be a full-blown DCSCM or not? And if they do, then any node could be the master, as well as all the other nodes being the devices. But equally, if somebody wanted a more traditional tap in, just plug a laptop in here, and this is your connection to the, this is your management interface, or a 1U node being a management interface. I guess there's a possibility there where we reside there. So, I mean, I've not really thought too much about it beyond that. Seems to be, I don't know, in my head, that seems to be a relatively straightforward view of the world. I guess with Jeff on the call, that is Jeff's entry into monitoring all of this. Maybe Jeff has ideas on the system management node.
So what I was trying to understand, trying to do here is trying to understand, right? So DCSM is, definitely DCSM as it is not going to work here, because DCSM is 1-to-1 ratio, and you do have multiple compute module and one module. So we have to have some kind of design done. But the bigger challenge is if you do the architecture the way you're thinking, right? Let's assume that you have 10 compute node, and then you have one node that does the system management. We have to have a pathway to upgrade those systems, operating systems, upgrade those system applications, upgrades everything for those other 10 nodes. And so they have to have a pathway from that management node that you're talking about to have a high-speed connection between the other nodes, so that you can push this to, push this big operating system or big or any kind of system firmware update, any other thing. So that needs to be tackled down, right? So that may need some special separate connection for that. That's what I'm trying to understand is, right? How if you do that, we definitely need to think about that, because that's going to be a challenging job to do.
Right. So, but that was where we were talking about this communication network here, right? Are you seeing the screen?
Yeah, I can see that. Yeah.
So we were saying that we'd have this network here, and this would be a gigabit network.
This one, sorry, Alan, is this talking to outside world?
Well, this talks between the nodes, and it could, there could be a link to the outside world from one of these, yeah, from the edge of the node. I mean, it depends. What do you mean by the outside world? In essence,
so outside world means like, I am an administrator, right? I'm managing 5 racks or 1 rack of these things, right?
Right.
And I am pushing regular security update to the systems. I'm pushing regular operating system update to the system, or installation of the operating systems or the systems, right? So, or maybe the firmware upgrade that I need. So I have to do it efficiently. So I can talk to the management node, and I can push. Let's assume that all of a sudden I might decided that I'm going to do, Linux update, right? Or some Oracle update, right? Maybe, 5, 10
so I presume you're thinking of an Ethernet link effectively.
Yes.
And anything specific? 1 gig, 10 gig, 100 gig?
Typically today, yeah, 1 gig is fine. I don't think that's a big deal. But system management is not a high-speed interface from that perspective. But that 1 gig needs to go and basically spread out between all the nodes, right? Because I need all the nodes to be simultaneously have their operating system updates or application updates, for example, right? So what I don't see here, how this 1 gig is, that 1 gig node is also connected between the 1 gig connection between there's FPGA has also, there is an internal connection between the nodes from this FPGA.
Yeah, so the idea of this one here, so well, first of all, we've got, so just to restate, we've obviously got all of these interconnects here, which are PCIe or would nominally be PCIe or CXL, right? Or stroke and CXL. So that's where you plug your media in. So if you had a processor and you wanted a 100 terabyte SSD, you'd plug the SSD into one of these slots.
Okay,
right? So you would be able to boot from, one would assume you'd be able to boot from one of these drives. Then we've got this topology interconnect, which you can still do interconnect between modules with cables on these, but just assume these are just media devices for now, for simplicity. We have our topology interconnect with these 8 connectors. And these can be Ethernet or PCI or NVLink or, you name it, they can be whatever you like. These are obviously 8 transceivers. And so we're talking, we're talking you know, 32 gigabits per second per link, per pair, all the way up to 224 if somebody is doing 224 Ethernet or something like that. So these are really quite high speeds. So, you know, do you really want to use? So you could use one of those to bridge into a management node if you really wanted to. And then we've got, then the idea here is we've got these, which probably will be 4 rather than 6, which we were talking about free air optical connectors between neighboring modules, is a mesh. So you create a mesh network of 1 gigabit. So we would have a little switch on here that can manage the traffic, and this could be an Ethernet network, or it could be something different. So at the edge of one of these nodes, we could either populate a management node, or we could or you could take one of these and have some level of interconnect where you turn this into a regular QSFP cable or whatever it is you want to plug into a neighboring server. So, you know, your management node. Or we have a dedicated module in its own right that has all of this on board and is a management module, and whether that's how that gets connected into the rest of the world. I mean, so there's, I mean, I'm failing to understand myself in a data center. All I've ever seen in the photographs is there's an IT guy with his laptop jacked into the 19-inch rack doing management stuff. So I don't really.
So typically, so Alex, a data center usually don't allow. Now, if you're talking about like a small,
so it'd be a cable that would go out of the network into the office somewhere, right? So into somebody's PC in the office.
So typically, yeah. So typically, in any, you know, any big data centers, right? They're talking about Google. These guys probably 5,000 away from the data centers, right? 5,000 away, right? So they're sitting over there. So basically, there is a top of rack switch, right? So typically, when you have a rack, right? For example, a rack may have 40 nodes or 30 nodes or whatever it is. From each node, there is a management port connection.
Right, so that's what so certainly between each node, rather than every node going to one ginormous Ethernet switch and all having management going to that, it would go through this mesh. So basically, each of these Lattice Avant devices so you'd have one Ethernet connection coming in through one of these links, which would somehow be converted into a regular Ethernet cable and pop into the regular network of the office outside the high performance
center, yeah.
Right. So you'd have one feed in, and then basically it would filter its way through a mesh network. And so basically you would act as every one of these would act as a 4-port switch. So either it would take the traffic in and say, oh, that message is for me, and it would work with it, or it would just simply say it's not for me, and it would pass it out to the rest of the network. So effectively, I mean, so the way I'm thinking of this is, you know, if you said let's do it with Ethernet, then this would be a 4-port. Every FPGA would be a 4-port Ethernet switch.
Okay, and then how this FPGA is connected to the CPU? What kind of connection and communication you have?
So we've got this. This is this one. So I work with IBM on the Power 10. So they got the low pin count interconnect, so the low end interconnect. You've got the PCIe, the dedicated 4-lane or whatever it is, 2-lane PCIe bus that connects, so it's Gen 2 or Gen 3. And then you have maybe a few other IOs. You might have an I2C between these, etc.
Yeah, so today, yeah, it's the connection is between PMC and CPU connection is a PCIe, but it's not a high speed, it's a Gen 2 or 2 lanes.
Yeah, that's right. That's my understanding, right? Yeah. So basically, if this was an Intel processor, they have the 4-lane PCIe, the EMI port or whatever. I can't. Anyways, it's a PCI port effectively. And I said we could do the same for an FPGA. That's what we're looking at.
Yes.
So yeah. So whatever a processor needs for its normal communications with the BMC, we're assuming that your Lattice device would support those.
Yep. So basically, what's going to happen is so Lattice device, the BMC needs to put the video out of video port, right? This console redirection, video port, and all those video things that they need to do from outside the wall, so they have to do it. Plus, what's going to happen is once I want to push an operating system update or new installation of any of this particular node, then I come through the FPGA, then I push the data to the CPU, and the CPU does the installation and scheduling, all those things. Okay, I got it. Okay.
Yeah. I mean, obviously, we're not going to have monitors connected straight to this. There's no USB ports. There's no, these are.
Yeah, this will be outside world. Yeah.
So you have to go out via these back to the management console if you want to get a video output, which will be a low speed video output. We're not talking high resolution gaming here.
No, but yeah, I think the console redirection will push the video out to the remote world. It's not the video, just a console, in the command control.
Right. The console messages, right.
So we need to. So let me do this then. I'm gonna write it up the deployment perspective, like on a console redirection, monitoring, temperature sensor, device presence, and all those things. That's a basic functionality BMC that we would need. That way, we at least know that this is the functionality, and then we can target what the details of this functionality, right? And the security is definitely another one that Alex is targeting, I believe, the Calypto and SPDM. Right. Okay. Yeah.
You happy? So it's a good question. We do really want to think about that from a hardware perspective. But yeah, I guess when we connect out, we're going to need to bridge one of these optical IOs into a regular Ethernet cable that comes out of the data center into the office or something for management control. And obviously, when you've got a grid of these, there are going to be a lot of ends all the way around the grid, or spare ends. So you have multiple ports into the network potentially, but one would assume you only use one unless you've got some more significant bandwidth needs.
Okay, no, I think I got it. The main region that we're thinking about FPGA, Alex, Alan, is that what happens in the traditional BMC, right? I think this is something that's important to explain why I thought about FPGA.
Yeah, right.
Yeah, so the reason is that when you go to the traditional ASIC route, you have to stay to all the standard interfaces, right? Because when you have any kind of non-standard interface, typically what happens is that you have to bit bank that interface to the ASICs, and then you're basically using the cores 100% of the time just to protocol translate for that particular one. Right. And if you look at the traditional BMC, it only has 2 cores, or in some cases, if it's the next generation one, they're coming up with 4 cores. But then if you keep this 2 or 3 cores busy continuously just to do the protocol translation, right? Because you all have all the new, everything is new here, right? All the protocols here we're talking here is new. So that's the reason I think we need an FPGA for that, because it cannot just use a standard BMC, and because it will be choked. Right. Okay. Yeah.
Right. You see, right. So you're when you're saying it'll be choked.
Yeah, because the standard ASIC BMC will be choked because it has a limited number of cores, right? Because
the standard one. No, absolutely. Yeah. No, I get it. No, absolutely, a standard one. And obviously a standard one, like an ASPEED, it actually has a south bridge that it also controls, which has all the video IO and all the rest of it, right?
Yeah.
So so we're really wrapping it all up into this one device.
Right.
For sure.
The regional standard, I was saying is standard ASPEED BMC. If I put it here, for example, right? It can do standard interfaces fine, but then when you talk about the interfaces through the CPU to this, is all new definition.
Yeah.
All new interfaces, and then you cannot. So to do that, you have to install the protocol on the software level, right? And when you do the software,
so I guess I'm thinking how many 1 gig ports can your Avant support? Do you have hardened IP for a gigabit?
You have a hardened IP for the PCI, yes.
but not for gigabit Ethernet.
We do have hardware for gigabit Ethernet, yes.
How many ports in in one of these Avant?
I think there is multiple versions of Avant. So there is like, small one like 200K has 2 port, but then up to 500K LUTs that we have on that not released yet, but I can give the spec on that.
Okay, I mean, so if we were just going to do raw Ethernet, then we'd want a sort of a minimum of 4 ports.
Right, we can do that. I think with the 500K device, that's the targeted application for that. So we can do
Right, you know, we have the option of potentially 6, but that was if we go in the other 2 directions as well. But in terms into a 3D mesh for Aberdeen. But okay, yeah. But again, once we get in our own network, we don't necessarily have to do entirely Ethernet. But to your point, if you don't want to change all the software and the way it all works, if we're acting as a switch as well as an endpoint in each one of these, okay, you're just passing through a whole bunch of Ethernet switches to get to a particular node.
Right.
Is the way it will look, which should work, I'm assuming, if it's over Ethernet.
Yes, should work.
And without changing too much of the software. Okay. So no, that was good. That's worth discussing.
No, it clears my mind too. I think I'm just probably a little behind in the architecture.
Yeah, and there is this optical I/O idea. I think this would be tremendously simple with our friends Avicenna, but we do need a sort of a. There are optical ways of doing this, but we could maybe do 10 gigabits per second, or easily do 1 gigabit per second, but we could even do faster if we wanted with some of the latest optical and just do a bit of free space optics between neighboring modules was the idea.
Okay.
All right. Okay. Jeff, any comments from you on all of this? You're observing it from the software perspective. I don't know if it's
Yeah, no, it's definitely interesting. Yeah, it's different than everything else I've seen, from my time at, managing systems and storage stuff at Sun. Would there be a way to get these slides?
Yeah. Well, they should already be published, but I can give you a link to them for sure.
Yeah. If you could do that or just forward them to me, that'd be awesome.
Yeah. This was our inaugural slide deck when we started this separate work stream. This was we did this in December last.
Yeah. Sorry, I wasn't around at that time.
No
It was my first time kind of going through it.
And this is actually this diagram generically has been around for about 2 years. So we haven't really moved on that far. Actually, and I'm not sure if I think you were both on the main call, but I'm sort of getting more for the end application is building an ASIC emulation accelerator feels like the right way to go. And with the Xilinx VP1902, they're big ASIC emulation FPGA. So where my head's at the moment is to actually try and get a module built for that. And so we're going to need this circuit put together. And so that's where getting a little bit of a pedal to the metal on that side of things would be good. And Munir, specifically on that, again, if we can get, I've been thinking about what tools do we use, and I like the open source, because if we can go open source as much as possible, then that's good for everybody. So there is this in terms of CAD tools, PCB. There's something called KiCad that came out of CERN in Europe, which has become pretty sophisticated. So if we do all that, then and we open source all the schematics, so somebody can just pick up this design and then just reuse it. The idea would be anyone would be able to build this module and use all of the components that are on the module as reference components if somebody wanted to put their own processor down on it. Anyway, getting a real module built, I think, is one piece of all of this as well, and the FPGA module seems like a good starter for 10.
Yep, I agree.
Um,
How
yeah.
would this thing manage all of the compute nodes that go into the wall? Is
Well,
there a particular slot that this,
no, this
I'm
circuit is
assuming this
actually
is its
part
own
of
thing, huh?
this circuit is part of the module.
Oh, this is part of each compute module.
Every module will have one of these. So, in
Okay.
fact, do you see the model here?
Yeah.
So if I strip down this model a minute, take the wall off, take the chip side off. There you go. So this is the main. This would be the main chip, like the FPGA we were talking about, with its power supplies here. We're looking at power supply infrastructure, and then on the top side, I was talking to Ferric, which is one of the power supply companies. So we're looking at some of their really tiny power supplies that we could put directly underneath the FPGA. This is your big chip, the controller chip that that Munir proposed. He's proposing a fairly big chip. It's 19 by 19, but there'll be multiple die in there. Like including the security device and some DRAM and the rest in there. Is that right, Munir?
Yep.
Yeah,
So-
so everything will be contained. The entire stuff will be contained in this one chip.
Okay.
And
And Munir, you're at what company?
Lattice Semiconductor.
Lattice. Okay, got it.
the FPGA company. So they've been doing quite a bit on the I2C side, and there's something called Libra BMC, which is open sourcing all of the RTL to the BMC hardware design, so that from a security perspective, everything's open source again. So this Libra BMC has been saying let's use FPGAs for that, and there's a Lattice and Xilinx examples of Libra.
And we
BMC.
do have an FPGA designed in some of the motherboards. Like I think Boeing uses our FPGA as a BMC for some of their motherboards.
Got it.
So any special features you want added in, Jeff, we put them in for your additional monitoring. If you
No,
want
I mean,
some extra, if you could see this, we would be able to do this much better, this monitoring much better.
Yeah, I mean the whole idea is we need to be able to get more through our design is more to be hardware agnostic and
Right.
more operating system dependent. So our goal is, we would come in through the OS to get access to the components and capture information about them. And then from there, we'll go off and manage those components and say, hey, this component's dead. We've got flapping issues on these items, et cetera, right?
Right. Well, so to a certain extent, I see the BMC is a much more sophisticated beast than it has been to date. In terms of there are certain situations where you don't necessarily need an OS. Like dedicated FPGAs or whatever. But equally, these FPGAs have SoCs in the corner of them now as well, so you can still run a full OS as well. So, but all of the above are possibilities if the way we go here. Anyway, this is the controller chip. These little ones here are the ICE40s that are basically taking all the sideband signals and converting them into single wire signals to go into this controller. And then the bigger devices were the clock tree that I was selecting. So that's really where we're at the moment. Still some work to be done there. But yeah, so all of this would be integrated into the module. Is the idea.
Mm-hmm.
That's
interesting. So
every module. I mean, effectively, this is like a server inside one of these modules. It's a full-blown server, effectively, just crunched down into a module.
yeah,
These are your SSDs and your memories, right?
And you remember what they used to call those in the day when they used to have those? A service processor?
A service processor. Oh, right. Okay.
Remember, every server used to come with its own service processor, daughter card on it to
Oh,
manage
really?
the server
Right, okay. Well,
before
yeah,
it was.
this is the big processor and the service processor on the back, sort of thing, is the idea.
Yeah,
So this can be any accelerator, any processor, GPU, FPGA, switch.
yeah, whatever they want to use.
Your switches can be, this can be a switch as well. That's the idea. And every big device has its own little controller doing its system management features and monitoring stuff, and ideally not getting in the way of what the processor wants to do.
And able to handle the heat from the processor.
And able to handle the heat from the processor, right? Exactly. Yeah, that's where all the thermal side of it comes in. Well, actually, to be fair here as well, in discussions with these power companies that are wanting to bring this backside power in, they're asking if we can move this one over to the side. So, I mean, we can probably do that. But anyway, so there, I mean, there is, we're not without our space challenges here, for sure.
Yeah.
So,
No,
but
it's interesting for sure.
yeah, but our point is everything else has been shrinking. The entire servers are now gone into a package pretty much. So why not shrink the 19-inch rack down to one of these modules, and then we can make these are serviceable units and they're self-boot, so they can operate in standalone, or they can be coordinated with a whole bunch of them. That's the idea. This could be a gaming PC for a kid. So he just plugs it into one of the walls at home, which is then piped into his HVAC system. So, the idea, the vision goes all the way to that. Okay, so on our last call, we did ask Alex to, as he seems to have a nice high level view of all aspects of this, certainly from an HPC perspective. And so he's put some words in here to really get us off the starting line, I guess, in this proposal. So maybe let's take a couple of minutes to have a quick read of this.
Yeah, some of this in here seems like it's is more around somewhat around configuration stuff. How to configure this thing.
Yeah, so this is a big piece of it. The machine, you turn it on, and every module wakes up and says, "Oh, I'm a standalone module," and then it needs to get So I'll boot myself. Yep, I'm up. I'm healthy. Anyone else around, or the system management device says, "Well, we're awake. Before I turn on my main processor, let me see who else is around." So
Yeah,
yeah, so there is a certain configuration boot. How do we get off our knees, sort of thing?
Yeah,
Yeah,
so
this is a standard typical management stuff, but I think what I'm looking at, he's also looking at Calyptra. Do you decided that you're going to use Calyptra or SPDM, or we don't know that yet, right?
This was just the conversation on that last call where we ended up down that route. And again, this is where I'm not entirely.
Yeah, the Calyptra still is in infancy stage.
Sorry?
The Calyptra still is being defined. I think today's SPDM is used a lot for the system attestation, device peripheral attestation.
it just seems to me, looking at this, as he's kind of mixing configuration management versus, like operational management stuff.
Right, yeah.
That's where it gets a bit confusing, because some of it is like the first bullet is more like, asset management.
Which
And then-
typically BMC does, right? BMC should do that, but then
Yeah, and then but he's calling it all physical management features, right? But you've got configuration management, that to me is separate from physical management. I guess I kind of think more of the physical management is more of the operational side, operational management stuff. But the configuration management is how do you configure this thing, how you want it.
Well, actually, I see physical management as the physical side of things. So, and how do you configure this as you want it, to your point? Or well, there's a certain amount of, when you say how you configure it, when you wire these modules together, because that's really where this is different. You've got to cable these things together as you want them connected, and that side of things is unknown to the system management at Poweron. And so but that is a configuration. I put 20 cables between two nodes, or I wire it in a mesh or a hypercube or whatever. I wire these things together.
Yeah, but is that managing? Is that managing or is that configuring? Because you keep using the word configuring.
Well, yeah. So you've physically configured the machine in a certain way.
Yeah.
And it's a physical thing. It's a physical configuration. And when you turn the power on, we need to do a discovery of that configuration with the configuration management software. So it says, oh, you've wired it up like this. Yeah, that's a legal one.
Yeah,
Or,
yeah.
hang on a minute, that's illegal. I'm not turning it on. You've wired this thing up illegally, sort of thing.
Yeah, and that's what I was getting at, is most of this stuff that I'm reading here is all more about the configuration.
So certainly the first bit
of the
is
system, right?
in the logical side. I've not read the logical piece yet, but yeah. So there is that. That's the first phase, right? Is a discovery. I almost call it configuration discovery, I guess, but it is a physical configuration discovery process that you're going through.
Yeah, but the second one
think-
is also providing an abstraction that allows users to manually compose nodes from the disaggregated devices. So that's a configuration thing too.
Right, yeah. So that's like from a CXL perspective of I need this much memory, I need 2 GPUs, one
Yep.
CPU, an FPGA. Oh, here they are. I've discovered them. They're wired up like this. I can leverage these ones for my needs. I'll have them, please. Now I'm running them. No one else can use them.
Yeah.
But everyone else goes and uses something else with a different configuration.
Yeah, and even the logical stuff down there is all configuration stuff too. Composing, the
Right.
system, subdividing
Which
it into pieces, the interconnect technologies. I mean, this to me sounds like a lot of, kind of configuration focused stuff.
Okay, well, yeah, no, agreed. So there's nothing wrong with this.
No,
You're
no.
saying it's missing your piece. It's
Yeah,
missing,
this is no, and this is all good. This is all good, right? You got to have it. I'm just the naming of it of physical management seems like when you use the word management, it seems more like an operational thing, versus a configuration thing is, you operate, you configure things, and then you operate and run them for the life of the machine,
what
right?
we probably want is a little preamble, this defining the meaning of these various things, because I can see that each of us can see the same thing in slightly different ways. And so what you're saying, Jeff, I think, is if we had a bullet point of what we mean by physical management is this, what we mean by configuration is that, in the context of the following paragraphs.
Yeah, and then the operational management pieces is how do you operate this equipment for the life of it, right?
Right.
You've got it up and running, you've got it installed, you've got it configured, and now it's running for 5 years, right? And you need to operate it.
Right. Well, not only that,
That's how I see it. But
well, obviously the composability is,
yeah.
well, you might dynamically allocate resources for a job, and once the job's finished, you free them up for somebody else to allocate. So,
oh yeah,
that's not fixed, obviously.
Yeah, you'll be constantly doing that, right? You know, and that's just getting things ready for the runs that you're going to have, you know, or how big of an application you're going to run and what resources it needs.
Right. Well, I'll tell you what, would you fancy just having a crack at editing this and adding your layer on top of it? This not in here.
Yeah, I mean, mine would be at a totally different layer, right, than this.
Yeah, that's what I mean. It's, well, first of all, trying to get clarification, because I think we're all, even between us here, I'm getting a feeling that we've all got subtly different views of what these different words mean.
Yeah.
So if you fancied doing a little bit of a bullet point explaining what your interpretation of each one of these pieces is, operational, not physical or whatever, and then maybe tweak this as necessary, and then add the layer of fault
Yeah,
prevention.
and I actually think it's easy. Just go up at the very top there. The second sentence, it says discussion into the physical and logical, and just add configuration management.
Where's that? Which is the second?
Second sentence, yeah.
Physical and logical.
Configuration management features.
There.
Yeah, and to me that identifies that this is, you know, that's what this is. So systems management, hardware and software development. So is that like an overarching bullet, and then so the title of it, of configuration management, would that be an overarching bullet of that? Would mine be a piece that fits under this, or would it be a separate piece?
Well, so look, this is literally a brain dump of of Alex. So at the moment, it's a case of we're completely unstructured. So it's up for grabs. Anybody that thinks that there's a better way to structure these things, and they've got a piece to add themselves, have at it. Is really where we're at here.
Yeah. Okay. No,
Just
just
think
didn't
about
know if
more
there was
like,
any other.
yeah, if we can put a high level requirement first and then go details about configuration management at a stage.
Yeah. No, we do. Well, the high level. I mean, I was hoping that maybe Alex would have done that. Really, is
Rather than deep diving.
I felt that he did have the higher level view of the whole thing.
Yeah.
And we've got the hardware and the software aspects. Obviously, this is more of the software aspects.
Yeah, what is that we need to do, and then we can define how we're going to do it, right?
Yeah, exactly.
Yeah, and well, that was what we said. We said we've got this booting phase, i.e. these configuration management phases, this discovery phase, and getting everything working together. We've got the uploading of the system, I guess, and management, and any software updates. All of that needs to go through everything. Then we've got the runtime stuff where we're actually beginning to log and monitor certain things. And then we've got this layer at the very top, which is analyzing the machine as it's running and saying something's looking odd here. I think we've got a module going down or something like that. Okay.
And you're expecting the customer would put any flavor of operating system on this that they would want?
Yeah, so that's where it gets to a level above what. So we got in this. This is my simple view of this, and you can shoot me down if you like. I mean, it is a topic that pops up quite a few times. There's a chap called Kevin Cameron that always raises the fact of the communication links and the protocols we should be using. We're very focused on, this is pretty simple. This is just physical hardware that we're trying to say, how can we make a Lego block physical hardware that deals with today's computing needs, with our view, with our focus purely on sustainability and energy-centric computing, as I call it. But being able to compose any machine for a particular application, and the composability gives you the performance and the efficiency needs as well. So we're literally just the physical components now. Because we're very modular, we're very Lego brick, we absolutely need a system management, a coordinated system management. So that's the only entry point into the software world that I want us to have, is at the management level. But if somebody wants to run one operating system, and the idea that to really emphasize the point is, if I wanted to rebuild a DGX box with this, I could, assuming the modules were available with the correct chips. I could wire it together and it would look exactly like a DGX box, and I could boot the software stack of the DGX box. That would be what we'd want to do without changing any of the software stack, or the software stack of a Tesla Dojo, or the software stack of whatever else, right? And the system management level would be there to facilitate that. Any of those existing software stacks would be the idea. So the beauty of it as well is that we also, with the features we introduce in a hardware perspective, we open up the possibilities of significant innovations in software stacks and hardware, heterogeneous hardware configurations that are pretty restrictive on the way we have it today. So that's the idea, that we open up the like, for me, for instance, the possibility that there is no operating system. It's maybe the operating system is managed by the system management chips. That is the limit of the operating system, which is what I used to do in the 1980s. We'd have heterogeneous processors, big powerful processors that would just crunch data at the kernel level, sort of thing. You know, but I'm not saying that's the way to go. You know, everyone will tell me, well, that will never work again. But that's a possibility if somebody wants to pull that thread, is where my head's at. And so that's where I'd like the BMC to become a much more sophisticated system manager, not powerful per se, but just sophisticated. And by the way, on that note, can you will you be able to boot Linux on your Avant device, Munir?
Yes, it will have a you know, built-in ARM processors.
And is there flash inside that package as well?
Yes.
And how much flash would there be enough for a Linux image?
I think it's typically 1 gig, but yeah, it should be good enough for
Okay,
Linux.
so you could run
We're
a
targeting for the BMC application.
Right. So
regular
there you go. I mean, to that point, Jeff, see, potentially you just have your network of thousands, like a Frontier supercomputer has 50,000 Linux processors in the system management that are running. They're doing all of the management features, while all of these mix of heterogeneous processors and accelerators are just getting on doing the job they're paid to do, the high performance compute job, and try and not get in the way with all of the other ancillary stuff.
So if I heard that correctly, so Munir, you're going to be putting an operating system on the management.
Well, you could.
You need to.
You could. We don't necessarily have to, but we could.
But if you are trying to do OpenBMC, that's a Linux system.
Oh, right. Okay. Fair enough.
Well, an OpenBMC has so many limitations to it versus just putting Linux on it.
No, agree. But I'm saying that you know, for the BMC, typically, if you have to build up something from the ground up, that's different story, right? That's definitely we can.
And that is the opportunity. We do have an opportunity to build something from the ground up here as well. But equally, we want to be able to just implement what's already been done. I mean, that's the beauty of this being the way it's been done, is we're trying to put the various interconnects in place for speeds and feeds and everything else that can make this quite a powerful system management level, whilst at the same time be able to support the very traditional software stacks and traditional BMCs, so that this just works out the box.
And also, like, I think the operating system you can have typically with the BMC world, right? They do the the sensor management through one of the cores, right? So our Avant is basically targeting for the BMC replacement. So, but there's definitely various version of this, Jeff. So we can think about which we need.
Yeah. No, definitely. And I want to bring in somebody else into that conversation on our side as well.
Sure.
Jeff,
that's
would you like to have a stab at this, because you're coming at it from the sky high level of manage when everything's in place and managing it all? Do you want to maybe add a paragraph or two or tidy this up a bit from your perspective?
Yeah, I think mine would be just completely separate paragraphs. I think that what Alex put in there is totally fine. I was just trying
so whatever's
to get some
missing,
clarification on it is all.
Yeah. So whatever's missing, and if you sort of, if you've got a way of describing it holistically and how it breaks down into the configuration management piece in your piece and whatever other pieces you feel that should be there, I guess I think between you, Alex, John from Intel, and Munir, we've got all of the diverse experiences to at least put the shape of this section of the document together.
Oh, totally. Yeah. I don't. Yeah.
And then to turn it into, well, this is what we're trying to achieve, and this is what we need to do, and this is what we need money to do.
Yeah. So if you scroll down though a little bit, John's not going to like that sub bullet that's not filled in.
The sub bullets is much. Oh, this one.
Yeah.
Yeah.
I guarantee you he's going to fight that one like crazy to get redfish in it.
And yes,
I've seen him before on other ones. Yeah.
No,
Redfish is the be all end all to him. It may not be for everybody else, but it is to him.
Well, and his job is to understand why it isn't, and he does say that, and what needs to change in Redfish to make it good for everybody. So I think that's healthy.
Yeah.
But equally, again, to get something off its knees, we probably need to be Redfish. If we implement OpenBMC, I'm assuming there's a lot of Redfish stuff in OpenBMC. Again, I don't understand the details, so but that would be a key piece.
Yeah, I think we can go either way, Redfish or IPMI.
Well, I definitely don't want to go IPMI. I'd put a bullet to my head if you do.
That's fine. Redfish is fine.
IPMI, SNMP, yeah, that's pretty wrong.
Yeah, we can go Redfish. That's not a problem, right? It's just
I mean, this again with an open community around this.
Yeah,
is like in the Open Power IBM, there was a ton of like university driven or small startups in Europe and the likes that were doing some very interesting stuff. But yeah, it's a case of, the nice thing about this being entirely open is it does allow for innovation from others, and if somebody wants to do a complete clean sheet of paper, then they can for a particular system. But yeah, they're taking on quite a lot of history, and it depends on the machine you're building. If the machine you're building is a brand new machine and you don't care about legacy, then you can do a good job. But that's the idea.
Yeah, and I would assume this physical configuration management piece would also be able to provide a view of how things are configured, right? Rather than lists of things, right? It's actually going to be this is connected. Here's your whole system as an image.
Yes.
This is connected to that, color coded, right? And here you drag and drop this over here, and now you've just connected those things together.
Right, exactly. Well, and that's, to be honest, I think that's probably the main software work that needs to be done here, is the overall management of this machine as it's physically constructed, and how this system management tool interacts with the other existing tools. And probably that bit needs to be the consistent piece, and the other pieces need to be like pluggable pieces where you say, oh, I want a completely Redfish compliant OpenBMC, and I'm going to plug that one in, you know, and something like that. So we might want to be careful as to what we take on. We only want to take on what we need to, which is specific to this hardware architecture, and then try and support what already exists or allow other people to innovate. And again, with it all being open source, then it's going to allow everyone to add in the hooks that they want to add in.
No, absolutely. Yeah, and that's what, right, when I was reading through this earlier when you had it up, I was thinking, wow, just having a tool that had this was like a visual tool.
Yeah, nice little product you could add to your portfolio.
Yeah, well, that's not what we don't do configuration stuff. We don't yet, but we plan to in the future, right? But yeah, it comes down to, you know, having this cool tool that had this configuration of these walls of stuff and how they're all connected together, and you can just drag and drop pieces to it to, you know, physically build out the sized machine that you want, right?
Well, or yeah, you could do that both ways, right? You could maybe, you know, architect a solution in a tool that then says, well, this is the configuration what I want. I want this mix of CPU, GPU, FPGA wired like this, and you get the wiring diagram, and you make the wall to the desired configuration. I mean, that
No, absolutely. And then, but have it be able to lock different things. So if somebody goes to drag something and change a configuration on it, but that thing's already being used by an application and running, you know, you don't want to have somebody not know, right? Human error, right? You don't know what you don't know. And then you start mucking with shit, and then somebody else yells at you like, what the hell did you just do? You just killed my shit, right?
Yeah.
And so to have the safeguards built into it, that is like, this system's locked down. It's being used by or owned by these individuals who are running their stuff on it. And it doesn't allow you to touch it or reconfigure it. They've locked it, and until they unlock it, it cannot be, you know, these resources can't be reused for something else, right?
Right. Yeah, I realize we've just gone over the hour, so
Yeah.
take up your time. But yeah, good discussion. So Jeff, I'm not sure if I've given you access, so I'll just give you access to this document. In fact, I'm going to just do it now. What's your email, Jeff?
G Mershon, MERSHO. Yeah, there you go, right there.
That's it. I got it. I'll put you through as editor.
Appreciate it.
You should get an email on that, so that should give you access to the document.
Does that get me to all of the New Frontiers stuff? Do you guys?
No, that'll just give you access to this particular document. You should already have everything. Should already be readable. So if you go to the wiki if you go to the wiki and you go to one of the main meetings, the minutes of one of the main meetings will have the links to the oh, in fact, sorry. We don't have the DOE. Yeah, so there's a link inside these minutes here. Main meeting minutes. There's a link to the New Frontiers draft there, though.
Okay.
And
If you just added that link to that main wiki page, then we'd all have it in one spot.
Yeah, I could do that. Yeah, I could put it on the main wiki page. I might do that.
I don't know if you have access to change the wiki or if
Oh yeah, no, I
have others.
I change it every day to.
Oh, do you?
all the recordings from the past calls I keep adding. So.
Yuki, you're the one that's doing it, not Michael. Okay.
No, that's right. Yeah, and yeah, so I could put this. I could put it in here actually. Yeah.
Yeah, and then it's all together, and then you don't have to have it in every meeting note you put it.
Yeah.
I mean, it doesn't hurt to have it multiple places either, right?
No, that's true. All right. Well, actually, I'll do that, and I'll put a link to the I'll put a link to our active response as well. So, but anyone that's not been, it just gives everyone viewing rights. We're fully open, so we share everything. Anybody can see anything. That's the idea.
Mhm. You
Okay.
just don't have edit rights to everything.
Right. Yeah. We don't want to give everybody edit rights because that could be dangerous.
Yeah. Now, do you know if the New Frontiers project, if they require, proof of history, with government stuff?
I've been having various conversations with people about you better have these certain credentials, which is why we want a sort of a system integrator involved that maybe knows how to work with the government or has worked with the government. But yeah, so I mean that is a level of detail that we haven't really got into. I'm talking to various people, like Bob Ciotti is one chap I'm talking to that used to be a CTO of NASA. He's now working for one of the value-added resellers that actually works closely with the government and sort of installs and maintains IT systems in the government labs. So they certainly know how all the contracts work. So they could work with a system integrator, for example. So yeah, those aspects of it are certainly a key part.
Yeah, because those requirements, if they say, so like I've got an Air Force contract. I'm also my product is embedded in IBM Federal Solutions.
Okay.
And I'm under partnership, subcontractor, purchasing agreements with IBM, as well as like multiple NDAs.
Right.
And they're going after as a prime opportunities to use that solution that has our technology in it, my technology in it, as well. And then I'm partnering with other system integrators, going after other
so
government
to be
opportunities,
fair,
like in like Department of Homeland Security, VA, other ones.
right. So well, put bluntly, if you can, I mean, I know IBM really well. I've tried a couple of times to get them to be our system integrator. I got close once, but I didn't quite get there in the end. And so, but if you're already plugged into these government entities with your own funding, and you're plugged into IBM, if you think what we're trying to do here might catch their interest and they would like to be the system integrator helping us all do this, or some of your other system integrator partners that you're working with might find this to be an interesting project that they could lead and drive, then bring them to the party, please.
So the IBM is going to be somebody who's not going to want to go after deals that are less than $100 million.
Right.
That's just who they are, right? That's how big they are. The big guys don't go after the smaller projects. And so they may not be the right fit. But there's also a side of this thing that says that, well, maybe they could build the whole hardware solution as well.
Right.
And that would be a different level of discussion.
But I think all it needs to be is it needs to be that we need this to be an IBM PC again. All these pieces need to be open so that everybody can play in this same sandpit. It can't turn into an NVIDIA DGX type platform or a Tesla Dojo or a Google TPU. It has to be something that the industry at the small player level can participate in. Now, if IBM said, you know what, we'll do all of this, and all of this we'll do the thermal and stuff, we'll do the, or we'll partner with certain small companies, happy days, right? So I'm not proud. The only thing I want is I want this to be an open platform. If I'm a silicon startup, I only need to build one HPCM module with my piece of silicon in it, and I can play games with other processors, or I could build a big scale-up system with just thousands of my processor, and I don't need to raise $1 billion from my venture capitalist because this open spec is in place and I can buy all the pieces from other people to build the big system. So that's only where my passion lies, is trying to bring a bit of democracy back to our industry.
Yeah, and I wasn't trying to say anything around. I don't know what IBM would do, right?
Well, no. So IBM, the lovely thing about IBM is once they can't make 10 times the profit of what, you know, or sell something for 10 times the price of what everyone else sells it for, they give up on it and they open source everything. So I mean, they're pretty good. In fact, they said on the supercomputing side, they only want to do stuff in the open source. So they were putting proposals in for this RFI where they were trying to say all of this will be open source, but it was their ideas as opposed to the way I'm structuring it. Their view of what we're doing here is this a PCI Gen 7 type problem. But
yeah. So IBM has two sides of the house, right? They have the commercial side that goes after commercial opportunities.
Well, they've got this research house, but the research house still says we got to make money out of this research in 2 to 3 years. So it's not research; it's just development.
Correct, exactly. But then there's the federal side that basically takes all of the product that they build for the commercial side, and they go build solutions with that for the federal side. Right?
Is it Ed Seminaro you're working with?
Who?
Ed Seminaro? He's probably
no, he doesn't ring a bell. I'm working with the folks that are going that are in kind of DoD
right
focus. So a partner.
Yeah, so Ed, you know, the big Power 7 torrent switch system was architected by Ed. Now, that was years ago, right? And that's a decade ago now. But yeah, okay. Well, no, those are the sorts of guys. Well, anyway, I mean, look,
I need to drop out.
Yeah, I need to drop as well. But basically, Jeff, if you can get anyone interested on the system integration side and they have the plugs into the government and even different forms of funding, bring them to the table. If we can get them excited about what we're doing and it's not all purely commercial. You know,
is there a way? Yeah, is there a way you could find out who won the last deal at ORNL and which system?
Well, so this is a little bit of an R&D research. So lots of people can do lots of little projects. But it's towards the big machine. But the last big machine was Frontier. And Frontier was an AMD machine with HPE, or Cray won it, but HPE bought Cray.
Oh, okay. So they were their own system integrator.
And the previous machine was IBM, the Summit machine with NVIDIA and Mellanox. That was 2018 deployment. So that's the two machines at Oak Ridge in recent history.
Yeah. So getting in with the commercial side of IBM might be the best play here, as I'm thinking, which is the folks who deal with and are focused on HPC solutions, right?
Yeah, I'm not so sure, to be honest. I think the DoD are the ones that are crazy enough to think this might be a good idea, and the commercial ones just don't. They seem to be taking different routes, more traditional routes.
Yeah, they do, but remember, IBM is also trying to, they're also trying to change their playing field, because if they could change the playing field, then they change the metrics in their.
Well, again, if you're talking to some of the people and you think they're,
yeah, I'm not talking with anybody in the HPC side of IBM, right?
No, I have been, and I got close to getting them convinced, and then it fell away, unfortunately. So,
is there one naysayer that you know that?
No, just there was there was the main architects that they had their own ideas, right? So not invented here, sort of, is where it ends up. So
got it. Okay, yeah, no, and that could happen, and it's more like a personal thing within a big company, right?
Yeah, but you know, I've had a number of interested advocates, but you got to convince the whole group of people, and it's a big company, right? So
Yeah. So I mean, I've got other system integrator folks I'm working with.
Well, if you want to introduce them to us, and you know, to see if they're interested, then
I think the point of a system integrator might come after we do a submittal and get selected.
well, I'm not sure because we might not get selected because we don't have the system integrator working the paths into the government. So anyway, yeah. So well, we'll
Okay.
see. I mean, we've got this system integration. We do have a startup that wants to have a system that's acting as a system integrator, and they're looking at partnering with various other companies. You know, like Penguin Computing does a lot with the government labs. Anyway,
Yeah. So no, I was thinking maybe Penguin as well. So but anybody who actually owns government contracts is who you want, not people who provide technology into people who own government contracts. Because the government contract folks is where you're going to get your historical, references.
right.
We've had all these government contracts and all these completed ones, and they've, added up to this many millions and, millions and millions of dollars. So we can handle this sort of a thing, right? That's the message you get across from the historical stuff. Which is why like the DHS contract that's out right now for small businesses, but they have to be either women-owned, HubZone, 8A certified, or what was the other one? Or veteran-owned. And that's all that can go after these deals. Just those small business set-asides.
Yeah.
And I'm talking with and working with a number of folks to go after that. And so as I go down this path, I'll have more connections into those folks that I'll already be working with.
Okay.
And they'll be able to leverage mine, but the DHS one, you have to have 5 completed government contracts as historical. And the bigger the size of those contracts matters more. So I'm working with connecting in with some folks that have some 8A statuses that can give them up to $100 million in non-compete business contracts with the federal government based on their status.
Right.
So as I work with them, I'll know more about that stuff. But I'm talking with numbers of different, of different folks that do system integration work as well.
Okay. All right. Well, keep your ear to the ground, basically.
Yep. No, sounds good.
I mean, we're, at the end of the day, we're open. Anybody can come anytime.
Yeah, and I think even in this proposal that you're doing, having folks in there like I've got all of the government accounts, right? I've got sam.gov, I've got DUNS, I've got cage codes, I've got everything. I'm billing government right now on my Air Force contract, and they pay me. So
well, maybe you could be the system integrator then for us.
I've got all of that, all of those things lined up with mine, and I'm also a HubZone company, which gives even greater advantages because the government has requirements of not only do we have to do small business, but the overall small business awards we have to do, so much of it has to be for HubZone companies or 8A companies or whatever.
Okay.
So I would hit the HubZone. I could probably pull in some system integrators that would pull in the 8A certified. And all of those capabilities are going to make the proposal look even better for ORNL because now they'll be able to check off all these other boxes that they need to check off and where they spend their money and how they spend their money because everybody has requirements of so much of your money has to go to HubZone companies, 8A small businesses, women-owned, veteran-owned, right? The more of those boxes we can check off in the submission, then
well, look, I
mean,
mean,
just pre-check off all these other boxes that they have to hit and make life easier for them.
well, so maybe, I mean, maybe you can help out just yourself and your company if you're interested, but like maybe we could dedicate one of the main meetings to you presenting on all these hub zones and like if the players that are willing to participate in this in our overall RFP response If you say, well, really get yourself registered here, there, and everywhere, and and that'll just set us up better for greasing the skids if they do like what we're up to. But anyway,
No, totally agree with you. But like I said, I'll be able to add context into this submission that says that, oh, unified points involved, and at this, SAM UID and cage code numbers, and we're a HubZone small business, and we've got previous contracts with Air Force Research Labs and stuff like that. Then those are just going to help bolster the submission, because we're going to start checking off a bunch of boxes that these guys need to check in and spending money anyway.
Right.
And
Well,
so
if you're checking off the boxes, all I'm saying is if you're checking off the boxes in your little bit of the contribution, if you could help us as a complete group in the overall proposal tick the boxes, then that would be, and whatever that takes. So I mean,
yeah. No, it's a lot of freaking work, let me tell you.
well,
Just
right. That's
Get-
yeah. Right.
getting these accounts set up and getting all this stuff done, it is a shit ton of work.
Yeah.
But adding another system integrator that maybe maybe an 8A certified, or veteran and 8A, and I'm already a HubZone, then we start checking off all these different boxes. It's finding the ones that can do other boxes that we don't already have checked is key, right?
Well, that'll be great. We haven't at no point had any conversation like this in our work group in the last 2 or 3 years. So yeah, good on you.
Yeah, but you're going after a government thing, and so government has these requirements, and it's you got to know about them in order to really bolster your thing, and they can make a decision based on, shit, these guys all have somewhat competing bids, but this one's going to check off all these other boxes that we have to do. That's going to make our lives so much easier.
Right.
That let's just do that one, right? Trust me, they make those decisions like that all the time.
Yeah.
So because it's really hard for them to meet some of these government requirements that come down that says how much you have to spend of this pot of money we gave you on these sorts of types of businesses.
Okay. Yeah.
Cool. All right,
So
I gotta run though. But
Okay.
Alan, good chatting with you. I
likewise.
could go into
Take
this
care.
stuff as well. It's complicated as shit, but
Yeah, no, that's good. All right. Well, thanks very much.
awesome, sir. You have a good one.
Bye.
Talk soon. Cheers.